The concept of green eyes is actually a massive oversimplification. Unlike brown eyes, which derive their color from actual brown pigment, green eyes are a visual trick. They are a masterclass in physics, lighting, and genetic architecture. If you were to look at the human population as a whole, true green eyes are incredibly scarce, estimated to appear in only about 2% of the world's inhabitants. But within that small 2% lies a spectrum of variety that is absolutely wild. We aren't talking about one color, we are talking about distinct structural phenomenons that create 7 entirely different visual experiences. By the time we reach the end of this video, you will understand exactly how light manipulates the architecture of the eye to create these stunning variations. And you might just realize that what you thought was one color is actually a complex optical illusion. Let's dive straight into the deep end with a type that often gets mislabeled but holds a fascinating secret in its structure, the aqua or turquoise variant. Imagine standing at the edge of a glacial lake. You know the water isn't actually blue paint, it is clear. But because of the way the deep water scatters sunlight, it appears as this piercing, crystalline blue-green. This is the perfect physical analogy for what we call the aqua-green eye. In the world of iris observation, this is often the most confusing category because it sits right on the border of blue and green. What makes this happen isn't a turquoise pigment. The human body doesn't produce blue or green pigments in the iris. Instead, this eye type relies on something called the Tyndall effect, similar to Rayleigh scattering, which makes the sky blue. In these eyes, there is almost no melanin in the front layer of the iris, known as the stroma. The stroma here is usually very fine, with a delicate structure. When light hits it, the shorter blue wavelengths scatter wildly. But here's the twist. There is a tiny, microscopic dusting of a yellow pigment called lipochrome. When that scattered blue light mixes with that faint yellow filter, your eye perceives a vibrant, sea glass aqua. It is a balancing act. If the collagen fibers in the iris were slightly thicker, the eye would look gray. If there were more lipochrome, it would look fully green. This specific type is essentially a moment of suspended animation between blue and green, creating a look that seems to shift based on what shirt you are wearing or the weather outside. It's not magic. It's just the physics of light scattering changing based on the ambient environment. Now, let's shift the spectrum to something warmer and earthier, a type that carries a heavy history in genetic research, the olive green eye. If the aqua eye is a glacial lake, the olive eye is an antique bronze statue or a sun-drenched forest floor. This variant is fascinating because it breaks the rule that green eyes must be light. Olive green eyes are characterized by a much richer, darker depth. They don't have that piercing, translucent quality of the lighter shades. Instead, they have a matte finish that absorbs light differently. Biologically, this is a result of a medium level of melanin. You have the same light scattering that creates the green base, but it is overlaid with a heavier blanket of natural brown melanin. Think of it like looking at a green light through a pair of sunglasses. The intensity is dampened, and the color becomes moodier and more complex. Looks like moss on a rock. It creates a soft, inviting look that many people perceive as trustworthy and warm, likely because it bridges the gap between the intensity of light eyes and the depth of dark eyes. From the earthy tones, we move to a type that is arguably the most famous, yet the most misunderstood, the true emerald. This is the holy grail of green eyes, the type you see on magazine covers. It is vivid, solid, and incredibly distinct. Unlike the olive or aqua types, emerald eyes don't seem to shift colors as much. They stay a potent, grassy green regardless of the lighting. To understand how an emerald eye exists, you have to imagine a prism. In these eyes, the stroma, that fibrous layer of the iris, is clear enough to scatter light effectively, creating a blue base. But unlike the blue-green eyes we discussed earlier, emerald eyes possess a much higher concentration of that yellow lipochrome pigment we mentioned. It is a simple equation from art class applied to biology. A strong blue scatter plus a strong yellow pigment equals a vivid, unmistakable green. Current observation in the field of iridology suggests that the glow associated with emerald eyes comes from the clarity of the stroma. The fibers are arranged in a way that allows light to penetrate deep into the iris and bounce back out, illuminating that yellow pigment from within. It is similar to how a laser moves through a gemstone. Because there is very little brown melanin to muddy the color, the green comes through with startling purity. It is a recessive trait that requires a very specific roll of the genetic dice, making it one of the rarest confirmed phenotypes in humans. Now let's disrupt the pattern. We've looked at blue greens, earthy greens, and pure greens. But what happens when the eye decides to be a chameleon? This brings us to the hazel-green variant. You might be thinking, wait, isn't hazel a separate category? In many medical forms, yes. But in the study of color mechanics, many hazel eyes are actually green eyes with a centralized burst of melanin. This is often referred to as central heterochromia. Picture a solar eclipse. You have a dark center surrounded by a flared ring of light. That is the structure of a hazel-green eye. The outer ring of the iris is a true green, caused by that same scattering of light we've been discussing. However, closer to the pupil, there is a distinct concentration of brown or gold melanin. The reason we classify this as a green variant is that the dominant impression, especially from a conversational distance, is often green. The magic of this eye type lies in its dynamism. Because the pupil expands and contracts based on light and emotion, the amount of green versus brown that is visible actually changes physically. When the pupil is small in bright sunlight, the green outer ring is maximized and the eye looks vibrant. When the pupil dilates in a dim room, the green is compressed and the brown center dominates. This leads to the common experience where people with this eye color say their eyes change mood. It isn't a mood ring. It is simply the mechanics of the iris curtain revealing or hiding different pigment layers. Let's take a turn into the shadows with our next type, the forest or hunter green eye. If the emerald eye is a sunlit meadow, the hunter green eye is the deep ocean or a dense pine forest at twilight. These are the darkest of the green spectrum and are often mistaken for brown in low lighting. The beauty of this type lies in its subtlety. It demands that you look closer. The biological difference here is density. Researchers suggest that in darker green eyes, the collagen structure of the iris is thicker. When the stroma is dense, it doesn't scatter light as aggressively as it does in lighter eyes. It absorbs more light. Combine that with a moderate amount of melanin, and you get a color that is rich, brooding, and intense. This type is fascinating because it challenges the idea that light eyes are purely about the absence of pigment. Here, there is enough pigment to create depth, but not enough to turn the eye brown. It is a delicate threshold. In a clinical context, we often see that people with this eye color have slightly more protection against UV glare than their pale-eyed counterparts, purely because that darker canvas absorbs stray light more effectively. It is a functional beauty, offering a gaze that feels solid and grounding rather than airy or ethereal. Now, we must swing to the complete opposite end of the spectrum. We have discussed the dark and the vivid, but what about the ghostly? This is the mint or pale green eye. This is perhaps the most ethereal and striking of all. Imagine a piece of frosted glass with a faint green light behind it. These eyes can look almost transparent. They are often described as piercing or icy, but distinct from blue ice. The science behind the mint eye is an extreme lack of pigmentation. Here, the stroma is very loose and contains very little melanin and only a whisper of lipochrome. Because there is so little material to absorb the light, almost all of it is scattered back out. It is the same principle that makes a cloud look white. The light is bouncing off everything. Because there is just a hint of that yellow tone, the scatter shifts from white-blue to a pale, minty green. Observational data indicates that individuals with this eye type are often more sensitive to bright lights, photophobia, simply because their irises let more light pass through to the retina. It is a trade-off. You get a stunning, rare eye color that looks almost supernatural, but you might find yourself reaching for sunglasses on a cloudy day. The aesthetic impact of mint eyes is massive because they create such a high contrast with the pupil. The black center looks stark against the pale iris, creating an intense, focused gaze that is impossible to ignore. Finally, we arrive at the rarest and perhaps most visually complex type, the golden or amber green eye. This is not to be confused with pure amber eyes, which are solid gold. The amber green eye is a green eye that has been gilded. Imagine looking at a green leaf in late autumn, just as the veins are starting to turn gold. That is the palette we are working with here. This phenomenon occurs when the lipochrome, that yellow pigment, is deposited heavily but unevenly. Instead of mixing perfectly with the blue scatter to make emerald, the yellow sits on top in distinct clouds or rays. It creates an effect where the eye looks green in shadow, but the moment sunlight hits it, it flares up with gold and copper tones. Evolutionary biology suggests that lipochrome is a fascinatingly unstable variable. Unlike melanin, which is fairly consistent, lipochrome deposits can vary wildly in density and placement. In these eyes, the result is a metallic sheen. It's a look often associated with animals, wolves or large cats, which is why this eye type is frequently described as wild or exotic. It is a reminder of our biological connection to the animal kingdom, a raw display of genetic variation that feels ancient and powerful. The interplay between the cool green background and the warm golden foreground creates a vibration of color that the human brain finds particularly stimulating to look at. So, why does any of this matter? Why do we care if an eye is mint, olive, or emerald? Because it reminds us that green is just a label we put on a complex reality. When you look into someone's eyes, you aren't just seeing a color, you are seeing the specific density of their collagen fibers. You are seeing the exact amount of melanin their ancestors needed to survive in their environment. The next time you look in the mirror, or the next time you meet someone new, take an extra second. Don't just look for the color, look for the structure, look for the light, look for the history written in the iris. You might just find a type we didn't even cover today. I would love to hear from you down below. Which of these 7 types comes closest to your own eyes? Or which one do you find the most captivating? Let me know in the comments. And if you enjoyed this deep dive into the hidden science of our eyes, hitting that like button helps us tremendously. Thanks for watching, and stay curious.